So I'm going to go over some radical expression basics. First off, some vocabulary, so we're all speaking the same language. When we see this, I'm sure most of you would say, hey, that's the square root of x. So some things that we call this part underneath, so that expression underneath is called the radicand. Right? It's whatever expression or number is underneath the radical symbol. And the little number that lives in this little crook is called the index. And when it's a square root, we typically don't write the index, but it's understood to be 2. So for this first expression, the index is 2, and the radicand is x. For this expression, the index is 3 exactly, and the radicand is x plus 7. So the most generic way that you will see this, it looks like this. The index gets the letter n. So here's my index, and we use the letter a most often for the generic radicand. And if you want to say this entire expression here, we say the nth root of a. So now let's talk about the domain, right? And since you guys all know about functions, right, it has to do with what we're allowed to take roots of. So here, if n, remember the index, is an odd number, the domain is all real numbers. We can take an odd root of any number. So for a function, what that might look like is f of x equals the cubed root of x. We can evaluate this for any value of x at all. Positive, negative, fraction, doesn't matter. All real numbers, as long as my index is an odd number. Okay. If the index is even, however, we have to be careful. And you can think about this. So let's say I ask you to do the square root of -2. And sure, some of you guys know about I. If you don't, it comes up in just a few sections. But we're going to pretend like we don't know anything about it, and we're going to say, oh, well, that's not a real number. There's nothing I can multiply by itself to get -2 out. So if n is even, the radicand must be greater than or equal to 0. If it's not, then we say we can't do it, it's not a real number. So let's practice simplifying, and then we'll do a couple of find the domain questions. So simplify, square root of 79. Okay. So absolutely it is 7. I'm going to take a roundabout way. It's a lead-in. I'm not just being obnoxious. So this 49 can be written as 7 squared. So now I have the square root of something squared. Well, as long as I don't have anything else hanging out in there, those two cancel, and I just get 7 out. Square root, index is even, of -25. Well, my radicand's negative. We can't do that, so at least for the next few sections, we'll say that does not exist, or it's not a real number, whatever the option is. Next one. Cube root, odd. Take the cube root of anything. So cube root, we're looking for the number that we can multiply by itself 3 times to get the radicand. So what times itself 3 times is -64? I'll let you verify that -4 cubed is the same thing as -64. So -64 is -4 cubed. If I take the cubed root of that, right, cubed root and cubing cancel each other, and my answer is -4. Okay. If we look down here, the opposite, negative sign out in front, we like to say the opposite, of the 5th root of -32. This is just to practice with our negative signs. So This one carries along. We save that for last. 5th root of a negative 32. If you think about how we just did it up here, right? I need 5 of the same factor to end negative, so that means that one has to be negative, and not many things, for us, they'll be nice numbers, so don't try to look for a decimal version. So the 5th root of negative 32 is negative 2. Notice I covered it up. I don't want to see it yet. Hey, there it is again. So now I have the opposite of negative 2, final answer, positive 2. And our last example, before we move on to our functions, I have a square root of x plus 6 quantity squared. So those guys would cancel, and what we get out is x plus 6. Now, here's where I said I want to talk about how it might be different for some of your teachers depending on how in depth you're going to go. So when this is a variable expression, sometimes you'll be required to slap some absolute values on it for your answer. Typically, this goes away within a section or two, so I tend to skip it when I'm lecturing this part. But if your teacher doesn't, be sure to add them in. Okay, so let's do just a couple of examples of determining the domain for a given function. So f of x equals the square root of x plus 2. So my index is 2, which is even, which means my radicand, remember who the radicand is? X plus 2 has to be what? Right, greater than or equal to 0. So domain, another quick little review, right? Set of all allowable x's. So the domain, what x's make this true? Well, we can solve that little linear inequality, x plus 2 greater than or equal to 0. Subtract 2 from both sides. X has to be greater than or equal to negative 2. Right, so that's the domain with whatever notation your teacher calls on you to use. Either one of those probably. So when your domain, well, when your index is even, you'll probably have domain restrictions. There are some exceptions. And if your index is odd, and it doesn't matter what odd number you put in there, how about 7th root of x minus 4? 7 is an odd number, therefore your domain, all real numbers. Right? Or this, right? Something that looks like that.